welcome back to my YouTube channel. This is second video in this series. Your favorite place to level up your data structures and algorithm skills. I am Prasandu Pereira and today we have got something super cool for you. Ever wondered how you could use a stack to make a queue? It sounds like bending the rules of data structures, right? Well, that's exactly what we are doing today. We are going to implement a queue using stacks, also known as queue stack. This is a favorite topic in coding interviews because it tested how well you understand the behavior of data structures, not just the syntax. First, we are see simply introduction stack queue. What is a queue? A queue is a linear data structure that follows the FIFO principle. What is FIFO? FIFO means first in, first out. Think of people lining up at movie theater. The first one to arrive gets to go in first. Okay, what is stack? Stack works on LIFO, last in, first out. Think of a stack of books. The last book placed on top is the first one you can remove. So, what's the challenge? Well, stacks and queues have opposite behaviors, but we can use two stacks to mimic the behavior of a queue. There are two common strategies for this. First one is making enqueue, push. Second one is making dequeue, it's pop. Okay, now we are talking about how to implement a queue using two stacks. Stack 1 to handle all incoming elements, and stack 2 to reserve the order when we went to dequeue. Here is the key idea. When enqueuing, we just push to stack 1. When dequeuing, we check if stack 2 is empty. If it is, we move all elements from stack 1 to stack 2. This reserves the order. Then we pop from 2 stack, which gives us the correct front of the queue. Now I simply explaining stack queue code and test this code how to run. Let's break it down with this neat Java implementation. Step 1. We create two stacks. Stack 1 is for enqueuing, it means adding elements, and stack 2 is for dequeuing, its mean is remove element. And we import Java util stacks. And enqueue operation. Public void enqueue in data stack 1 dot push data. And dequeue operation, public in dequeue if stack 2 is empty, move element to stack 2 if it empty. If stack 2 is empty while stack 1 is empty, stack 2 push stack 1 dot pop. Return statement now return stack 2 dot pop. Public boolean is empty. Now can you see dequeue error is almost done, and that's how you build a queue using to stack in Java, a clean and clever thing using fundamental data structures. Let's break this down. When we want to remove an element, we check if stack is empty. If it is, we transfer all elements from stack 1 to stack 2, and this reserves the order, making the oldest element come on top of stack 2. Peak operation, same ideas, but instead of removing the element, we just return the front, and is empty, just check if both stacks are empty. Complexity, enqueue is 0 brackets in 1, dequeue is 0, and when transferring is needed, but amortized over many operations it's efficient. Now I call return statement now stack to peak. Now we calling testing main method. We add test cases in the main method. Now stack q equal new stack Q is out, NQ 10, 20 and 30, Q dot NQ 10 and copy and paste, change 20 and 30 is out, peak double dot and plus Q dot peak. Sorry. Print 10 is out, DQ plus Q DQ, remove 10 is out, DQ plus Q dot DQ. Remove 20 Q NQ 40 is out, peak NQ peak remove print 30 is out, DQ double dot and plus Q dot DQ. So, no, sorry, remove 30 is out, DQ double dot and plus Q dot DQ sorry, remove 40. Is Q empty, Q dot is empty. Now we get output of this code. It is successfully run. Now we are talking about real life analogy. Okay, let me give you a super relatable analogy. Imagine you have a pile of books. It's step 1. You keep adding books on top. That is like NQ. Now someone says, hey, you can give me a first book you have placed, but It's at the bottom of the stack. So what do? You take off all the books one by one and place them in another stack. It's stack 2. Now the first book you add is on top of the second stack. You just pop it off. That is DQ. Okay, now talking about consumption and engagement. This is such a cool trick and a classic interview problem. So make sure you practice this maybe to week it, and when try the costly NQ version if you are up for a challenge. If you enjoyed this video, learn something new or have a question, hit that like button, subscribe if you haven't already, and drop a comment below. What real life analogy do you think fits a stack queue? Your answer is comment in comment section. I hope this video helped clarify the concept of stack and queues for you. If you have any question and want to me cover other data structures, drop a comment below. Thanks for watching this video.